An introduction to artificial intelligence and cybersecurity. Artificial intelligence makes it possible for machines to learn from experience, adjust to new inputs, and perform human-like tasks. Computers can be trained to accomplish specific tasks by processing large amounts of data and recognizing patterns in the data. AI performs frequent, high volume tasks reliably and without fatigue, but still requires human input to set up the system and ask the right questions of the data. AI adapts through progressive learning algorithms to let the data do the programming. The algorithm has the ability to adapt when given new data. Subdomains of artificial intelligence. Machine learning is the science of getting computers to act without being explicitly programmed, used to develop practical speech recognition, effective web search, and product recommendation. Machine learning is so pervasive today that you probably use it dozens of times a day without knowing it. Deep learning is a class of methods and techniques that employ artificial neural networks modeled from the human brain. It is used in analytic applications, especially those focused on natural language processing, medical diagnosis, network security, and image identification. Machine learning at its most basic is the practice of using algorithms to parse data, learn from it, and then make a determination or prediction about something in the world. The two main branches include supervised learning and unsupervised learning. There must exist an ample amount of data to apply a machine learning algorithm. Machine learning algorithms work to estimate the mapping function f of output variables y given variables x such that y equals f by x. In supervised machine learning problems, we start with a dataset containing training examples with associated correct labels. The supervised learning algorithm attempts to learn the relation between the training examples and their associated target. Supervised machine learning subgroups include regression, which tries to predict a continuous quantity such as a dollar amount or weight. A classification algorithm predicts a discrete category such as colors or yes or no. Some algorithms include linear regression, random forest, and support vector machines. An error function is used to determine the accuracy of the prediction against the known targets. A regression uses R squared and root mean squared, while classification uses accuracy, precision, recall, or F1 scores. In unsupervised learning, no labels are given to the learning algorithm, leaving it on its own to find structure in the input. It is used for pattern discovery and feature engineering. The main methods include clustering and dimensionality reduction. In clustering algorithms, groups of data are grouped by similar features, including k-means clustering and hierarchical clustering. Dimensionality reduction looks for a low-dimensional representation of the data. A principal component analysis attempts to find data features that capture the highest amount of the data's variance. In k-means clustering, our data points are grouped into k groups by creating k centroids and assigning each data record to one of the centroids based on its proximity to the centroid. Deep learning imitates the workings of the human brain in processing data and creating patterns for use in decision making. It requires a large amount of data to train the model and have the ability to continuously improve and adapt to changes in the underlying data. A neural network is organized into layers made up of interconnections between the nodes. The weights are adjusted based on the error between the predicted output and the label of the training set. The weights are then optimized to reduce the error. A cybersecurity AI system works by learning a baseline trace system and then flagging anything unusual for human review. Dynamic malware are difficult to detect with conventional systems because they evolve over time. Once a model knows what malicious code looks like, it can identify unknown code as malicious or benign with extremely high accuracy in real time. Machine learning algorithms will help businesses to detect malicious activity faster and stop attacks before they get started. Attackers use AI to develop intelligent malwares, viruses, as well as constructing complex social engineering strategies. Fighting malware is a modern arms race as malware has evolved to be more evasive and harder to detect. Traditional malware detection systems utilize signature-based methods and are only capable of performing well on previously discovered strains. It is implemented using a variety of different algorithms, including k-means, decision trees, and naive Bayes, and it uses a training set containing file features. If the training set is corrupt, the algorithm won't be able to distinguish between clean and malicious files and deliver unreliable results. A dataset containing useful features is used to train a mathematical model that can accurately classify subsequent files or actions. AI solutions don't rely on having seen a particular piece of malware before and can identify new malicious files and executables. The model must have the ability to continually learn about new types of malware because attackers are constantly releasing new versions of malware files that differ significantly from those that have been seen before the training phase. Likewise, software companies are producing new types of benign executables that are significantly different from previously known types. The training samples must contain useful features for being able to create a boundary between positive and negative malware samples. The dataset is a matrix of rows and columns and includes a column that contains the correct label for each record, that being benign or malicious. The label column is denoted as Y, while the feature column is denoted as X. A simple linear regression model makes predictions by learning a set of weights denoted as beta, where beta 0 is the y-intercept and every other value in beta corresponds to a feature in X such that y equals X transpose times beta. We can then predict an incoming malware file is benign or malicious by using the formula for multivariable linear classification, such that y equals the y-intercept plus beta 1 times x1 plus beta 2 times x2 plus beta n times xn. An intrusion detection system is a technology which ensures confidentiality, integrity, and availability by attempting to not allow the intruders to bypass the security mechanisms of a network or host. They work by either detecting forbidden and suspicious activity or by detecting normal activity and alarming of anything that is not normal. Traditional IDSs attempt to match events and scenarios to rules that define denied or allowed patterns. Rule-based IDSs are not able to deal with dynamic and complex attacks. The adapted methods used in machine learning can result in higher detection rates and lower false alarms. Network-based IDSs are placed on a network to capture and analyze the stream of packets flowing through the network. They raise alarms for the network traffic entering or into or exiting the network devices of an organization. They use classification algorithms to differentiate the normal traffic from the anomalous traffic. Neural networks can automatically learn low-dimensionality reductions of a malware from its API call sequence. Features used to detect patterns include attributes such as packet size, port number, or address. There are several types of neural networks that derive from complex and imprecise data and can easily extract patterns that are too complicated for humans or other computer techniques to extract. The types include perceptrons, feed-forward neural networks, recurrent neural networks, autoencoders, and Boltzmann machines. The difference between the amount of hidden layers and the arrangements of the connections and nodes in the topology. Biometric authentication relies on unique biological characteristics or behaviors of an individual. The systems compare biometric data that is captured to data that is already confirmed and stored in a database to manage access to physical and digital resources. Biometric authentication systems can operate in two modes. Identification mode, we have an identity, no identity is claimed from the user, and the system must determine who the user is. In verification mode, the user provides an identity and the system accepts or rejects the users according to a successful or unsuccessful identification. We can verify users in two ways. Physical recognition uses unique characteristics of the human body such as face, iris, or fingerprints and transform them into a code understandable by the system to match a user's identity with a set of allowed users. Behavioral recognition uses behavioral characteristics such as a person's typing rhythm and other ways of interacting with a device to provide continuous authentication and verification during a user session. There are several types of biometrics, such as facial recognition that uses features such as the distance between a person's eyes. Fingerprint uses features such as the ridgeline patterns on a finger. Machine learning methods can be used to match a new sample against a record in a database and output a probability that the sample is a match, allowing the user into the system if the probability is above a threshold. Behavioral biometrics learn patterns in human behavior and continuously improve user profiles that can be used to validate sessions or transactions. A user's behavior profile contains features such as tap duration, swipe speed, fingerprint area, session duration, and device acceleration. A model is used to continuously provide session authentication by repeatedly updating a user's profile as new activity occurs. As time goes on and a person uses the device more, their behavior adapts. Machine learning allows for continuously learning new patterns and updating user profiles. Cyber attacks and AI. Lowering the cost and time consumption to carry out a cyber attack can effectively let hackers identify potential targets quicker and at lower cost. Using AI methods to learn how to modify the code in ways that make it undetectable by signature-based systems. Data poisoning introduces misleading data into the training dataset that skew the defense system's underlying model decision boundary. A virus can monitor emails of the compromised victim, then AI could tailor phishing messages to mimic the message style of the victim, allowing an attacker to create detailed emails that would very effectively target these individuals. Machine learning could facilitate advanced spear phishing emails to target at high-profile figures by training on genuine emails and teaching the algorithm to create emails that look convincing. Phishing email attacks are already bypassing spam filters, and hackers are beginning to train models to learn new and more efficient ways of bypassing spam filters. Basic level email automation provides cyber criminals with approximately a 5 to 10% success rate. Advancements in machine learning increase the success rate to up to 30%. Machine learning algorithms will help businesses to detect malicious activity faster and stop attacks before they get started. Machine learning algorithms will help businesses to detect malicious activity faster and stop attacks before they get started. And the rapid development of AI-based attacks is a growing concern for security professionals, as criminals are ultimately innovating faster than security defenses can keep up with.